Okay, so now that you've implemented and synthesized your design, then go ahead and click OK to open the implemented design. So here you have your FPGA displayed on the screen. So if I zoom in on this section over here, you'll see the logic on the FPGA has been configured for your design. And if you look on the left side here, you'll see some other blue squares. These squares represent the I/O ports to your design. So Vado will automatically map the top level signals to these ports. So if I look here, I have my reset signal, and if I click through these other ones, you can see that the different bits of the count signal coming from my counter module. If I click and zoom out and zoom into this region over here, I have my clock signal. So now that you have your design implemented, we're going to go ahead and assign the correct I/O ports that we want for this design. So we're going to be connecting the count signal to the LEDs on your Z board, and we're going to be connecting the reset to one of the switches, and then finally you're going to be creating the clock for your design. So let's first go ahead and create the clock. So if I go over here on the left side and hit edit timing constraints, now here it says double click to create a clock constraint. So I'm going to double click here. So here's going to ask for my clock name, so I'm going to call it Z-board clock. And here I have to specify the source object. So I have to specify which signal in my design is going to be connected to this clock. I'm going to click this icon here and hit find. And here it gives me a valid list of signals, 1-bit signals I can use as my clock. So I'm going to hit clock right here and click on this icon and then click OK. Now I said we're going to be doing a 100 megahertz clock, so that's a speed of 10 nanoseconds, so that's fine. And then rise and fall at 0 and 5 nanoseconds, that's fine as well. So I'm going to go ahead and click OK. So now that I have my clock here, and then I'm going to hit here to actually add the clock. And then I'm going to click apply. So now that we have our clock, let's go ahead and connect all the I/O ports. So we'll go over here and click on I/O planning. And if you look at the bottom here, you can see your different signals. So we're going to do two things. One, we're going to connect the right I/O ports to your signals, and then we also need to change the I/O standard. So the I/O standard basically says how much voltage to go to each signal. If you put too much voltage, your Z board might overheat, so it's important to set these to the correct values. So for this count signal, I'm going to click here, and I'm going to hit LV-CMOS 18. Now before it did say default, but this value will cause a synthesize error because this default value here is not compatible. So you're just going to have to hit it again to make sure that red default signal goes away. And then I'm going to do the same thing for the clock and reset. Okay. Now I'm going to go ahead and connect the signals. So from count 7 to count 0, I'm going to connect these to the LEDs on the Z board. So just type these in with me. So for count 7, I'm going to put U14. Count 6, I'm going to put U19. Count 5, I'm going to put W22. 4, I'm going to put V22. Count 3, I'm going to put U21. And followed by U22. T21. And T22. Okay. Then for my clock, I'm going to connect that to Y9. This is the clock port on your Z board. And then I'm going to connect reset to R18. This is one of the switches on your Z board. So now that I have all the signals connected correctly, what I'm going to do now is go ahead and generate my bit stream. So I'm going to go over here on the left side and click generate bit stream. And it's going to ask me to save my design. I can go ahead and say save for now. And then click OK. It's going to ask me to save my constraints. So I'm going to say just to update my constraints file. And I'm going to ask me to create a constraint file name. So right now I'm just going to call it just constraint file. And then click OK to create the file. And then click yes to this. So because you have to replace the IO ports, it has to resynthesize your design again. So this might take a little bit.